All right, here we go. Day 2 of our final exam cheat sheet development. Today, we're going to be covering 5 questions. In video number 1, we covered 4 questions, the opening 4 questions to your final exam. All of them came from chapter 2, or sorry, they all came from chapter 1, right? In this video, we're going to move into chapter 2. There will be 4 questions from chapter 2, and we're going to finish off with a question from chapter 3. Okay, so in this video, again, just to remind you, these pink indices for each of the questions, this refers to a chapter and section where you can find the notes, more solutions, more materials, resources, that sort of thing. You can reference those in our archive. Okay, then I'll tell you how the question is phrased, and then we'll go through an example problem demonstrating technique and what kind of scratch work I'm expecting. All right, so kicking off problem number 5 here on your final exam. Okay, we're going to be starting here with chapter 2. Chapter 2, the name of this unit was polynomial equations and factoring. Okay, so quite obviously we're starting to deal with these long sentence polynomials. And for this first problem, in section 1, we simply looked at adding and subtracting these polynomials. And if you need to write this in your margin, essentially all we're going to do in this problem is combine like terms. So in other words, y squareds can only combine with other y squareds if there are any. Solo numbers will only be able to combine with other solo numbers, y's, so on and so forth. Okay, we'll jump into that in this problem. Okay, and what we'll do is we'll simply do the operation. Your first problem will involve subtraction between 2 polynomials, however long they may be, and we'll combine like terms. And when we go through that operation, we'll have a resulting polynomial sentence. These parts of the question will refer to what to do beyond that point. So the first thing we'll do is we'll perform the indicated operation. Then we'll revisit each of these key terms. First off, we're going to be asked to rearrange it into standard form. Again, when we get a result, like kind of how you see with this opening polynomial right here, it's kind of jumbled up with the exponent values, right? And so what we're going to be tasked with doing is reordering it more like this second polynomial, where it's in what we call descending order. Okay, so once we get our result, we want to rearrange it in the standard form by putting the biggest exponents first and then kind of walk it down after there. Okay, so that's what standard form refers to. Degree and leading coefficient will refer to, once it's been rearranged in this standard form, degree and coefficient will deal with whatever the term in front is going to do. And the reason why those are important is because they end up kind of determining the shape of whatever graph descent may end up looking like on a coordinate grid. Okay, so let's just go ahead and jump right into the problem. We are tasked here with a simple subtraction between 2 polynomials. So this will ultimately break down to a combination of like terms. But the first thing I want to deal with is the piece that most students mess up on these kinds of problems, particularly subtraction problems. Because anytime I have a parentheses subtracting another parentheses, essentially what's happening here is this minus sign is distributing a -1 throughout that other parentheses. And a lot of people get confused and thinking of like, all right, what happens when I subtract a positive or subtract a negative? Okay, if you're okay with that and comfortable with it, you don't have to do this step, but this will be mostly just to help clarify for the people that do get confused on that kind of arithmetic. All right, so what I'm going to do is I'm going to get rid of these parentheses, and really what I'm going to be doing is I'm going to be distributing that minus sign throughout this guy. So nothing's really going to happen with the values here in this first polynomial. It'll still say negative y squared plus 2 plus 2y to the 3rd power plus y. Nothing really changed there because it's the leading parentheses and there's nothing in front over here to distribute. But now I'm going to technically be distributing a -1 throughout this guy. So when I say minus a positive 4y to the 3rd power, it will read as minus 4y to the 3rd power. Basically taking that positive 4 and turning it negative. When I say minus a -3y, well, anytime I subtract a negative, that becomes plus. And when I subtract a positive, then that stays minus. Essentially what happened here is I took each of the signs and I just flipped the sign, right? But the reason why I went through that effort right there is because now I don't have to worry about like reading these parentheses, and I can just read it as the object it is. Okay, so now I'm going to combine like terms. And again, we should all be familiar with this process essentially of combining like terms, because this is something you've probably been doing since middle school. I usually like to work from left to right, okay, like reading a book. And my suggestion is, because of how many terms you see here, and you will have quite a few on your final exam, my suggestion is this: as you work from left to right, just cross them out as you go, okay, on your scratch work. That way you don't lose track of anything, because what's one of the most common mistakes is like you get through it and you lost track of one of the terms, like the numbers or y's or whatever it might be. So anyway, we'll see that done. So with this negative y squared, it can only combine with other y squareds. Well, there are no other y squareds. So that negative y squared stays negative y squared. That guy's done. All right, just working left to right. Now I have a positive 2. Just make sure you're keeping track of these signs in front of the values. So I have a positive 2. The 2 can only combine with other solo numbers. The only other solo number here is this guy, a negative 5. So positive 2, negative 5 will combine to make negative 3. And those guys are done. Okay, and you could see why I crossed them out, because there are so many objects, it'd be very easy to lose track of them. And particularly if you got to the end, you're like, oh, shoot, I forgot to combine one of them with another one. It's a quick way to check your work so you don't lose track of that stuff. All right, let's keep working. All right, next one up, I have a 2y to the third power. This can only combine with other y to the third powers. There's one right here. So I have positive 2, negative 4. Combined, they make a negative 2, y to the third power. And these guys are done. Almost done. Last two terms, positive y, positive 3y. Combine them together, I get positive 4y. And those guys are done. Nothing left over. That's part of the reason why I do it. I double check to make sure I didn't miss anything. And now this is my result. This is the result of the original subtraction operation I was required to do. But now I have to think back to what the question is asking for. It asked for 3 things. The first thing it asked for was it wants me to rearrange this into standard form. Okay, I'm not going to change this polynomial at all. All I'm going to do is I'm going to rearrange where these objects go. So that's in what we call descending order. Namely, I'm going to look for the biggest exponent here, this guy, the y to the third power, and I'm going to take that object and throw it in front. Okay, now it's a negative 2 y to the third power, so that's going to be moved up in the front to make it a negative 2 to the y to the third power in front. Okay, so that guy's done. Again, I'd use this little cross out thing to just make sure I don't lose track of anything. Next highest exponent is this guy, negative y squared. So I just throw that down next. Got him. Next highest one would be the singular y's, right? Positive 4y. And the last guy here is this minus 3, the one that doesn't have a variable at all. And that will go onto the back end. This is now in what we call standard form. The largest exponent is in front, and it walks down after that. Everything is in what we call descending order in regard to the exponents. Technically, this variable has an exponent of 1. And also technically, there's a variable here, just be y to the 0 power, or 1. Okay, don't need to write that, but this is in descending order. Great, so that's that key term. We were asked to also identify 2 other things: degree and leading coefficient. Now, degree and leading coefficient are really just going to depend on a single term in this result. Okay, and it's that front term. Once I've rearranged it into this descending order, into this standard form, I'm really only going to care about this guy right here. All right. Degree refers to the highest exponent in my results. Well, that will be this front term since it was rearranged to be in that order. So the degree here is simply what is that exponent. The exponent is a 3. This is a third degree polynomial. Leading coefficient, just to remind you what the word coefficient means, coefficient refers to the numbers multiplied by variables. So for instance, in this first term, negative 2 is multiplied by the y to the third, so the negative 2 is the coefficient. This object's coefficient would be negative 1 technically. This one would be a positive 4, and this one would be a negative 3. So the leading coefficient refers to, once it's been rearranged into standard form, the leading one is obviously the one in front. So the negative 2 is that coefficient for that leading term. And that's our problem number 5. All right, let's move on. So staying here in chapter 2, section 1, again, that problem that we just did, involved adding and subtracting polynomials. As we advance a little bit deeper into chapter 2, we're going to deal with some other more intense operations. Okay, so for this next one, this will be pulled from chapter 2, section 2. Section 2 had to deal with multiplying polynomials. So you're going to be given these instructions. You're going to be asked to find the product. And again, product is just a fancy term for saying the answer to a multiplication problem. And then you're going to be given polynomials that are multiplied by each other, like so. That's a binomial term, 2 terms. It's going to be multiplied by a trinomial term, or 3 terms. So this is the type of thing that you will see for your problem number 6 on your final exam. You're going to be asked to find the product. Quite obviously, there is multiplication happening here. I have 2 objects that are multiplied by each other. They just happen to be parentheses, polynomials. Okay, and so just like with any thing that I have multiplied by parentheses, I'm going to be using the process of distribution. The difference here is that I'm going to be multiplying multiple objects through that using distribution. Okay, and so I'll use 2 different colors here. Okay, typically what I would do with my solutions, I would actually show you these paired up. So I would actually show you x times 4x squared, x times negative x, x times negative 7, so on and so forth. But right here, I think I'm going to, for the sake of time, just go ahead and jump right to what is x times 4x squared. And so for this first term, whatever it happens to be in your final exam, for this first term, I'll go ahead and use blue. So I'll do x distributed throughout this parentheses using blue. For this second term, this positive 3, I'll use pink. And so the positive 3, as it's multiplied throughout this, I'll show you what that looks like as well. But I have to do both throughout that next parentheses. So let's use blue for our first term, x. So when I multiply it through, x times 4x squared gives me 4x to the 3rd power, because there'd be 3 x's. Moving on, x times negative x would give me negative x squared. X times negative 7 would be negative 7x. And I've finished going through with the x. All right, now that I'm done with that object, I'll move on to pink for my second object, this positive 3 right here. So that positive 3 also has to multiply throughout this parentheses. Positive 3 times 4x squared gives me positive 12x squared. Positive 3 times negative x gives me negative 3x. And lastly, positive 3 times negative 7 gives me negative 21. All right, and I've finished distribution. Now I have this very long polynomial sentence. My job will now be to collect like terms. Essentially, this is exactly like that last problem that we did, where we added or subtracted polynomials. Essentially, all I'm doing is collecting like terms. So x cubed, or x to the 3rd power, can only go with other x to the 3rd power. There are no other ones here. So my final result will have that 4x to the 3rd power. That guy's done. X squared, or x to the 2 power, can only go with other x squareds. There's another one right here. So negative x squared and positive 12x squared will give me positive 11x squared. And these guys are now done. X is my next value. Negative 7x can only combine with other x's. There's another one right here. Negative 7x and negative 3x would make negative 10x. And these guys are done. And lastly, I have one lonely object left over, a single number, that negative 21 will stay as is. That guy's done. And this would be my final solution. No need for rearrangement there, because both of these polynomials were already in standard form. So that would be my result in that case. And that's problem number 7. All right, that one wasn't too bad. Let's keep going. Problem number 8, also from chapter 2. This will be from chapter 2, section 4. Chapter 2, section 4 covered solving polynomial equations. So your instruction here for this problem, you will be asked to solve a given equation. Just to remind you about what the task of solving entails. Solving means that there will be a variable hidden in some way into the equation. Your job is to isolate that variable so you get that variable equals some value. Okay. Now this one will be a factored form of a polynomial, similar to this. Okay. So obviously this is a little bit different than the last couple of problems because I have an equal sign to some value. The fact that it's equal to 0 will be significant in this case. Okay, but we're going to be asked to solve here. So my job is to get A by itself. Now I have a problem that A is in multiple locations. Okay, now what we learned for this section was that essentially what's happening here is I have string multiplication. Essentially I have 3 objects that are multiplied by each other. A couple of them just happen to be parentheses, but object number 1 would be this 2a, object 2 would be a minus 9, object 3 would be a plus 4. I have 3 things multiplied by each other that have to equal 0. So according to something called the zero product property, if I multiply any number of things together and the product happens to equal 0, something in there has to equal 0. There's no other combination of numbers that could give me a product of 0. What that also means is that if any individual one of those objects is 0, it doesn't matter what the other ones are because 0 times anything is 0. So here's the strategy we'll end up using for this one. Of these 3 objects, I'm going to set each of the 3 objects equal to 0. So for instance, object number 1 is this 2a. If 2a equals 0, it doesn't matter what happens in either of these parentheses. 0 times that string will be 0 still. So that will end up providing me one of the solutions. But also, if object number 2, a minus 9 here, if that happens to equal 0, then it doesn't matter what 2a or this other parentheses are because 0 times those things will equal 0. And the same thing will be true of this last parentheses, object number 3, this a plus 4. Essentially what I'll do on this problem is I could have had 9 different things multiplied together to get 0, and I would have just had 9 different equations. None of the individual equations are terribly difficult, okay, but that will represent the number of solutions. And I'll end up solving for the variable in each of these. So for instance, in this first one, if I want to get a by itself, I need to move this 2. The 2 is multiplying by a, so I need to move it by division. And if I were to divide both sides by 2, 0 divided by 2 is still 0. And a equals 0. That is one of the solutions in this problem. Because if I plugged in 0 for these a's, this one would end up becoming 0. And then it doesn't matter what happens in these two. 0 times those things is 0. This is a solution. I'll do the same thing here, but now it'll just be a different inverse operation. In order to get a by itself, I need to add 9 to both sides, and I'll get a equals 9. There's solution number 2. Here I would have to subtract 4 from both sides, and I will get a equals -4. If a is any one of these 3 numbers, this entire string will equal 0. That is how we go about solving problem number 8. Great. Done. You know, I'm realizing that I did that out of order. That is technically not out of order. Forgive me. That's technically problem number 7. Now I'm about to do problem number 8. I don't know where I lost track in there. Just ignore those quotes from before. So now we're doing problem number 8. This will be from section 2.6. All right, in section 2.6, this was really a culminating experience type of section where the other namesake in this chapter, the chapter name is polynomial equations and factoring. Okay, so in this section, we dealt with this task, factoring completely. So just to remind you what it means to factor something, factoring is essentially the inverse operation or the undoing of distribution. Distribution involves multiplying something throughout a parentheses. Factoring undoes that. So when I multiply throughout a parentheses, like we did in the past couple problems, I end up with a polynomial sentence. Factoring reworks it back into its parentheticals, kind of like in that last example where I have a series of parentheses multiplied by each other. That's what we're going to be doing with this factoring. And so in this case, you will be given an actual polynomial, like such. Okay, 6x squared plus 3x minus 18. Okay, so the difference with this problem is now instead of giving the parentheses, now I'm giving the actual polynomial sentence. In this case, what I'm going to be asked to do is to factor it and move this back into its series of things multiplied by each other to give me this result, or a series of parentheses. Okay. Many of you have multiple techniques for solving this kind of problem for factoring, and I'm okay with you using those techniques. Just make sure you show the work for what you did. And many of you already do that. So I will demonstrate the technique that I covered in section 2.6. It involved X method / table method. But yeah, we'll go ahead and jump right in. Okay, task number 1. Anytime you were asked to factor a given polynomial, there's something you want to check for first. In this case, I have 3 terms. It's a trinomial, a three-term polynomial. Is there anything in common between these 3 terms? And the answer is yes. 3 goes into each of these terms. Just a 3, that is the greatest common factor, but it is a factor nonetheless. And what happens is if I were to factor out a 3 or divide out a 3, I'll be left over with stuff. And again, it's division because with distribution, that's multiplication. Factoring is the inverse of that multiplication, meaning that I'm dealing with the opposite of multiplication, which is division. And so when I divide out this 3 from this first term, 6x squared, I'm left over with just 2x squared. And I can confirm that I did that right, because if I were to multiply these back together with distribution, I'd get right back here. All right, so for the second term, positive 3x, if I were to divide a 3 out of that, I'd be left over with just a positive x. And then if I were to divide this 3 out of the negative 18, I'd be left over with minus 6. And again, I can confirm I did that correctly, because if I were to distribute this 3 throughout the parentheses again, I'd get right back to where I was before. All right, so again, step 1, always make sure you're looking for greatest common factors. I know this is the greatest common factor. There's nothing more I could have pulled out because there's nothing left in common inside that parentheses. Okay. All right. Now what I'm going to do is the real task of this will be factoring this trinomial now. And this is where I'm going to use my X method technique. Many of you have other ones that involve grouping that it's similar in nature, but the work would look a little bit different. And I'm okay with you using those other techniques. Just make sure you're showing the work. All right, so I'm going to use X method to go about factoring this guy. And so this will look familiar, hopefully. Right, X and table. All right, and so what I'm going to be doing here is for the top of my X up here, I'm going to take the first term, this 2x squared, and multiply it by my last term, this negative 6. And that will give me negative 12x squared. The bottom of my X is the other term, the middle term, in this case, positive x. All right, and my riddle now is what 2 numbers will multiply to make this first number that also add to make this number? Namely, what 2 numbers will multiply to make negative 12 that also add to make positive 1? And I'll jump right to the solution there. The answer is positive 4 and negative 3. 4 times a negative 3 gives me negative 12. 4 plus a negative 3 gives me positive 1. And I would add in these x values right there, because x times x gives me x squared. And when I add x's together, I get x's back. Okay, so these values right here were what I was looking for. And many of you that do these other techniques of grouping and stuff like that, these would end up being how I would split this middle term up into positive 4x and negative 3x, and then I would do the grouping technique beyond that. So I'm okay with you showing that kind of stuff. All right, but I'm going to use table method at this point. So in this top left-hand box, that's going to be the first term in my original trinomial, this 2x squared. The bottom right box is my last term here, this negative 6. Now, in these diagonals, that's what is going to be my result of my last X method, or basically what 2 items multiply together to make that top, that also add together to make that bottom. So I have a positive 4x and a negative 3x. It actually doesn't matter which one goes where, okay, just as long as you have both. Now what I'm going to be doing is I'm going to be looking for common factors in both columns and in both rows. All right, so for instance, in this first column, 2x squared and 4x, my greatest common factor here, they both have a 2 in common, and they both share an x in common. So 2x is my greatest common factor there. And again, I could go through the same thing for each the other column in both rows. Another way I could attack this is that this piece right here has to multiply by something to make 2x squared. That something here is another x. This x had to multiply by something to give me negative 3x. That something is up here. That something would be negative 3. And then this 2x would have to multiply by something to give me 4x. That something is 2. Each of these would also be the greatest common factor for the respective rows or columns. And what I've just created on the outside here, these are my parentheses. This positive 2x minus 3 and this positive x and positive 2 end up being the factored version of this 2x squared plus x minus 6. Now, please don't lose track of this guy, the thing we pulled out at the very beginning. That positive 3 greatest common factor at the very beginning is still a factor of the whole thing, and I have to make sure I include that with my full factored version, because now this would be the completely factored version. All right, again, if you need to see a little bit more demonstration of those techniques and stuff, feel free to reference Chapter 2, Section 6, and a lot of the other sections in Chapter 2 have that as well. But there is problem number 8 officially. I think I lost track of it on like the second problem or something like that, but that was problem number 8 on your final exam. All right, last problem for this video. We're going to cover problem number 9 on your final exam. This will be the first problem from Chapter 3. Chapter 3 dealt with graphing quadratic functions. And this problem that we're going to be doing will be referenced in Chapter 3, Section 3. Chapter 3 in its entirety was about graphing quadratic functions. Quadratics, just to remind you, dealt with these parabolic U shapes that are somewhere on the coordinate grid. Okay, and so they have lots of features about them. I'll go ahead and jump right to what the function will be. You're going to be given some more in-depth instructions here. I just wanted to kind of save some space. Okay, so you're going to be given in function notation something like the following. Okay, it will be a trinomial. It will be a quadratic. And the quadratic element of this is this x squared piece. That's what gives it its parabolic U shape. Okay, so you're going to see a function like this. And the reason why it's section 3 is the first 2 sections were just kind of more condensed versions of this very same type of structure. They're all quadratics, though. Section 3 just kind of encompassed all 3 of these terms. Okay, so you're going to be given a function. You're going to be asked to do several things from that. The first thing you're going to be asked to identify is going to be what we call the AOS. This is just an abbreviation for axis of symmetry. The axis of symmetry in a parabola, let me just give you a little bit of a demonstration here. So you don't need to write this part, but a parabola, a U shape, this is the general shape of an x squared graph. Now, had this leading coefficient been negative, it would be a sad face and an opening downwards, but we'll use this for the sake of this example. Okay, so this is a symmetrical shape, right? This U shape, and it's symmetrical because there's a line that can chop it in half. Perfectly in half, so that if you were to fold it over on itself, it would completely overlap. That's kind of the fundamental definition of symmetry. Okay, and so this axis of symmetry is a vertical line that chops whatever this may look like on a coordinate grid. It's what chops it in half. And the axis of symmetry is a location. And if I can find out where this vertical mirror is somewhere on the coordinate grid, it kind of fundamentally tells me where my U shape is located. That's why it's important. The other piece I'm going to be asked to find and identify is what we call a vertex. Now, the vertex of a parabola is basically on this axis of symmetry. It's the piece of the parabola of the quadratic that touches that axis of symmetry. Another way to think about it is it's the extreme point of my U shape, basically the bottom of my U, or if this had been a sad face, it'd be the top of the U. But those are the things I'm going to be asked to identify first. Okay, so how do I go about identifying that? You may recall a very simple formula, negative b over 2a. Negative b over 2a. Now, b and a represent coefficients in this original function. Now, here's what I'll remind you. We went more into depth into this in Chapter 4. We're obviously not there yet in our cheat sheet, but a is going to be the coefficient, the value, the number that's multiplied by x squared. B is the coefficient that multiplies by x. And c is going to be the one that has no x at all. It's going to be just the solo number. We don't need c for this calculation. But b is going to be this positive 8. A is going to be this positive 2. So when I plug these values in, I would end up with a negative version of B, or a negative 8. And on the denominator, I'd have 2 times A, or 2 times this positive 2, which would be 4. And this can reduce. Negative 8 over 4 would be negative 2. Great. Negative B over 2A is negative 2. So what? How do I use that? Well, that negative 2 value for that negative B over 2A, that negative 2 value is going to be used for this axis of symmetry. That's what we ended up solving for. So my axis of symmetry is a vertical line that can be represented with the equation x equals. And x equals in this case is going to be that negative B over 2A result, or that negative 2 value. This is a vertical line that, if I were to graph it, would be a vertical line if I had gone 2 units to the left. That will be the mirror that chops whatever my parabola looks like on the graph in half. All right, I'm going to end up using this value to help identify my vertex. And the technique in which I'm going to be using it to identify my vertex will be how I also complete my XY table for ultimately graphing this quadratic. Okay, so in order to figure out what my vertex is, I literally need to take this x value and plug it in to my function. So this 2x squared plus 8x minus 1, I'm literally going to plug negative 2 into that. So that's going to involve saying, like, all right, well, 2 times that negative 2 squared plus 8 times that negative 2 minus 1. Okay, so let me take the time to actually plug in that negative b over 2a value, that negative 2. All right, so at this point, it's essentially just going to be calculator work. I just have to be careful about order of operations. Got to start with my exponent. Negative 2 squared is negative 2 times negative 2, or positive 4. That positive 4 times 2 gives me 8. So this is how I usually show the work for it. This little chunk here, this first term, is 8. 8 times negative 2 will give me my second term. That's going to give me negative 16. And my last term here is just this minus 1 on the back end. All right, well, now I just have to do this arithmetic in order. 8 minus 16 is a negative 8. That negative 8 minus 1 gives me negative 9. Great. Well, what do I do with that? Again, what I originally had to identify was what is called the vertex. The vertex is an actual coordinate point. It's a location on a graph. And what we have created is a coordinate point. When x is negative 2, negative 9 pops out the other side of my function. That is the definition of a coordinate point. So in this case, my vertex is the coordinate point negative 2, negative 9. And I've identified the first two pieces of this graph. Next, what I have to do is a little bit more of the same, but essentially at this point, I need to create an XY table. But here's the good news. I have one of the coordinate points for it. That vertex is I'm going to be needing to make 3 coordinate points to really give me the shape of this U. And this negative 2, 9 is the middle of those 3 coordinate points. What I would do here, pick a value less than that, pick a value greater than that. Okay, so for instance, a value greater than negative 2 would be like negative 1. A value less than negative 2 would be like negative 3. And what I'm going to do is I'm going to plug each of these values back into that original function, just like we did to find this value. And so here's where I go through that math again, right? I'm going to have 2 times that negative 1 squared plus 8 times that negative 1 minus 1. This one's going to be 2 times that negative 3 squared plus 8 times that negative 3 minus 1. And both of these will spit out results. Okay, but let me just plug those values in really quick. I'll let you kind of explore the calculator work here. But what essentially would happen is that after I do this work right here, negative 1 squared gives me positive 1. Positive 1 times the 2 gives me positive 2. 8 times a negative 1 is a negative 8. That positive 2 minus 8 gives me negative 6. That negative 6 minus 1 gives me negative 7. I've just created the coordinate point negative 1, negative 7. Here's some other good news. This is a symmetrical shape, meaning that if I went the same distance this way that I did this way, this value should match. You can confirm that. I'll let you check that out on your own. But what I've just done is I've created 3 coordinate points. How will that be used in this problem? Well, what you will be given is you'll be given a multiple choice at this point. you'll be given 4 different graphs to choose from. What you are looking for the correct graph is this coordinate information translated there. So for instance, the vertex right here, this -2, 9, right? I'd be looking for something back 2, down 9. Okay, I'd be looking for a vertex down there in that general location. And then this -1, -7, and -3, -7 would go something like this. So I'm looking for this kind of happy face parabola right here. And so of the 4 options that you will have for this problem for your multiple choice, you'd be looking for this location and general shape of your parabola, and that would be how you would ultimately decide and finish that problem. And that's where we'll go ahead and end this recording. We'll pick up with problem number 10 tomorrow in tomorrow's video. Have a good day.